This is the Math 1050 Unit 4 practice exam. Question 1 is from section 5.2, solving system of equations involving more than two variables. This one, because there's three acid solutions, we're going to have three variables. So step 1 of any story problem is identify the question. The question's right here. How many milliliters of each solution should be used? So I'm going to let x equal number of milliliters of the 10% solution. And then y will equal number of milliliters of the 20% solution. And z is going to equal the number of milliliters of the 40% solution. Now we need to create the same number of equations as we have variables. If there's three variables here, we need three equations. So equation 1 is there's going to be 100 milliliters of this solution. So the end goal is to have a solution that contains 100 milliliters at 18% concentration. So the first equation I'm going to make is going to involve this number here. So more than likely the chemist is going to combine all three acids, the 10%, the 20%, and the 40%. She's going to combine them all together to make this solution right here, 100 milliliters at 18%. So the first equation I'm going to make is combining all three solutions, x plus y plus z, to first equal just a plain 100 milliliter amount. The next equation I'm going to make is going to address the concentrated amount, which is 18%. So this chemist is still going to mix all three acids together, but now I'm going to use the concentration amount. So she's going to mix x milliliters at 10% concentration, so that's 0.1 x, and then she's going to mix y milliliters concentrated at 0.2 or 20%, and then she's going to mix z milliliters concentrated at 40% or 0.4, and that's going to equal, again, 100 milliliters, but now because we're addressing the concentration, it's concentrated at 18% or 0.18. Now the final equation is going to come from this statement right here. She has to use 4 times as much of the 10% solution. So that 10% is going to involve the x variable. As the 40% solution, that is going to involve the z variable. So x and z, and because I need to form an equation, there needs to be an equal sign here. Now, x is not equal to z. It says here that she has to use 4 times as much of the 10% solution as the 40% solution. So I know that these numerical values are not equal to each other. This statement right here says that the numerical value of the 10% solution is already 4 times as much as the z solution. So for example, just throwing out random numbers, if we find out that this chemist has to use 20 milliliters of the 40%, then according to this statement, she's going to have to use 80 milliliters of the 10%. So the x variable is already 4 times as big. So if I want these two numerical values to equal each other, because this one is already 4 times as big, I need to multiply the z by 4 so that they have the same numerical value. So there's the three equations. Now, to solve this, I'm going to go ahead and multiply right here. 100 times 0.18 is 18, and then I'm going to subtract the 4z and get this equal to 0. Now we need to solve a system of three variables, three equations. From this third equation, we can see that y is already eliminated. There's no y variable. So what I'm going to do is use these top two equations and eliminate the y variable. what that'll do is give me an equation in terms of x and z, which I can combine with this equation, to form a smaller system of two equations, two variables. So to eliminate y from the top two equations, I'm going to multiply that top equation by negative 0.2. And 0.2 times 100 is 20. So now I have opposite coefficients here for the y variable. So I can add and eliminate the y variable. And actually, this needs to be negative 0.2, or negative 20, because I multiplied by negative 0.2. So that needs to be negative 20. And I get negative 2 right there. So you see the result of that step was an equation in terms of x and z. Here I have an equation in terms of x and z. So I'm going to take this equation, combine it with this to make a new system of equations. And solve for one of the variables. So we need to get opposite coefficients either on x or on z. So what I'm going to do is just multiply this equation by 10, because that's going to move the decimal 1 to the right, and then change that to negative 20. So this becomes negative x plus 2z equals negative 20. That'll eliminate the x variable. So then z is equal to 10. So we know now that we need 10 milliliters of the 40% solution. And according to this, we need 4 times as much of the 10% solution for whatever we get for z. So if we get 10 milliliters for 40%, that means for the 10%, we got to multiply that by 4. So x is equal to 40. There's only 100 milliliters that are going to be used in this mixture. So if there's 10 milliliters of the 40%, 40 milliliters of the 10%, that's 50 milliliters. So there's only 50 milliliters left over for the y. So y is equal to 50. So our answer is going to be 40 milliliters of 10%, 50 milliliters of the 20%, and 10 milliliters of the 40%. Okay, question 2. This is also from section 5.2, which is solving a system of linear equations involving more than two variables. So we have x, y, and z here. I am going to eliminate x. I see here that z has opposite coefficients. I'm going to avoid eliminating z just in case there are infinitely many solutions and we have to parameterize. It's a little trickier to do that, to parameterize the solution. If we've already eliminated z as the first step, we can still do it. It's just a little trickier. So I actually would avoid eliminating z first if we have 3 equations and 3 variables. So I'm going to take this top equation and the bottom equation and eliminate x. Now I'm going to take the top equation again, and then I'm going to take this middle equation here and multiply it by -2. So I can eliminate the same variable. So this equation right here is the middle equation multiplied by -2. So I can eliminate x again. And that's actually positive y, not negative y. Y minus 3z equals -1. So what we typically do is we take the result from step 1 and the result from step 2 and create a new system of equations. But you can see, obviously, it's the exact same equation. What that means is we're going to end up with 0 equals 0. Everything would cancel. If I multiplied the bottom equation, for example, by -1, all the variables cancel and the constants cancel. So we have 0 equals 0, which is an indication of infinitely many solutions. So according to this, if there are infinitely many solutions, then state the solution in terms of a parameter t. This is what we practiced in section 5.2. And the way we did it with 3 variables is we start by letting z equal t. So what we do now then is solve for the other 2 variables, y and x, in terms of t. So if z is equal to t, I'm going to use one of these equations from this step or this up there, and they're the same ones, so it doesn't matter which one I use. I'm going to use this one, y minus 3. Instead of 3z, I'm going to say 3t, because z is equal to t. And then add the 3t to the other side. And so now we have the value of z, and we have the value of y. We just need x. So to find x, I'm going to use this middle equation and then substitute. I'm going to put the value of y in for right there. And then for z, we're going to replace it with t, and then solve for x. So if you combine terms, this is a -3t. If I add a t, that's -2t. Here I'm going to have a +1 because it's a negative times a negative. If I subtract that +1 from the other side, I'm going to get a 1. If I add the 2t over, now we have the value of x. So our solution is, instead of x, it's 2t plus 1, and then for y, it's 3t minus 1, and then for z, it's t. Question 3 is from section 5.3, finding the partial fraction decomposition. So first step is to find the form of the partial fraction, and remember that's determined, the number of partial fractions is determined by how many factors there are of the denominator. There's 2 factors, so we're going to have 2 partial fractions. And just remember, sometimes, matter of fact, more often than not, the denominator is not already factored. So you may have to factor the denominator first to determine the number of factors, which will tell you how many partial fractions there are going to be. Okay, step 2 is we want to create an equation that does not have any fractions. So we're going to multiply both sides by the lowest common denominator, which is x minus 3 times x plus 5. And we distribute to each term. So when the lowest common denominator distributes to that term, it's just going to cancel out, leaving the 9x minus 11. When we distribute to the a partial fraction, the x minus 3's are going to cancel, so then a would multiply with x plus 5. And then when it multiplies to the b partial fraction, the x plus 5's would cancel, so then b is left multiplying the x minus 3 factor. So if you recall at this step, we now need to find the value of a and b. And because we're solving for a and b and not for x, it doesn't matter what the value of x is. So the way we described this in class was choosing a convenient value for x. And the reason we need to do this is we only have one equation to use, but we have two variables, and we can't solve for two variables with only one equation. So if we can choose a convenient value, -5, for example, for x, -5 plus 5 is 0. 0 times a means that the a portion of this equation disappears, leaving only b to solve for. So I'm going to let x equal -5, and then we would plug -5 in for all of the x values. Here, -5 times 9 is -45, minus 11 is -56. Here, -5 plus 5 is 0, so this term disappears. -5 minus 3 is -8. So b is equal to 7. Now we're going to do the same thing, choose a convenient value to cancel b so that we can solve for a. So to cancel b, we need to let x equal 3. And then plug 3 in for all of the variables. 9 times 3 is 27, minus 11 is 16. Here we have 3 plus 5, which is 8. And here 3 subtract 3 is 0. 0 times b is 0. So b disappears. Divide by 8, and we get a equals 2. So now the final step is to rewrite the partial fractions, replacing the values of a and b for what we found in this step. So this partial fraction becomes 2 over x minus 3. And this partial fraction becomes 7 over x plus 5. Question 4 is from section 5.4, solving nonlinear system of equations. So this one here is a quadratic. It's actually a parabola that's turned sideways, and this is a straight line, a linear function. We don't have to graph this, but just to get an idea of what we're dealing with, it's possible that this linear function, the straight line, crosses through the parabola twice. So we may have two solutions here. Now, we notice a positive and a negative in front of this y variable, but because these are not like terms, y squared and y, we're not going to be able to use elimination method to eliminate y. However, if we multiply the bottom equation by -2, we can eliminate the x variable. And then be careful when we're adding these two, since they're not like terms. It's y squared plus 2y, and that equals 0. So what we have here to solve for y, we have a quadratic equation. If this were a value other than 0, like 6 or something, we would subtract the 6 over and then factor. Since we have two terms, it already equals 0. I'm just going to factor out a y. And then we have y equals 0 and y equals -2. So what we need to do now is solve for x for each separate y value. So when y equals 0, I'm going to use this bottom equation here, 3x minus y equals 5. So when y equals 0, this bottom equation becomes 3x minus 0, or just 3x, equals 5, so x equals 5/3. When y equals -2, here we're going to have 3x subtract -2, which is +2. So 3x equals 3, x equals 1. So we have two solutions here. When x equals 1, y equals -2. And when x equals 5/3, y equals 0. Okay, question 5 is from section 5.5, linear systems, or not linear, these could be nonlinear. This is a parabola, this is a circle. So these are system of inequalities. Inequalities means a couple of things to be mindful of. Remember to shade, and then remember to determine if the line is solid or dotted. So I'm going to start with this first one, x squared plus y squared. Remember, when x and y are both squared, it's a circle. The square root of this value is the radius. So the radius is 3, and the center of the circle is at the origin. And because it's less than and not less than or equal to, it's a dotted boundary line. So there's our circle. To determine where to shade, I'm going to choose a test point of 0, 0. If x and y are both 0, we have 0 plus 0. 0 is less than 9, so that's a true statement. So the test point I chose needs to be in the solution area. So that's inside the circle. Now this one here, I'm going to move the x squared over by subtracting it. So we have -x squared plus 3. Now this goes back to our very first unit, which was transformations of functions. The negative in front of the x squared means it's going to flip upside down, the parabola. And because this plus 3 is outside the function, it moves up 3 units. So the parabola moves up 3 units and then flips upside down. So the vertex is at 3, 0, and then it's upside down. Now we need to have a couple of other points on the parabola. So if I let x equal 1, for example, 1 squared is 1. 1 times -1 is -1. -1 plus 3 is 2. So when x equals 1, y equals 2. And we can use symmetry to reflect that point. And because it's just less than and not less than or equal to, again, this is a dotted boundary line and not a solid boundary line. And now we need to determine where to shade. So I'm going to use the same test point, 0, 0. If I let x equal 0, then here I've got 0 plus 3, which is 3. Over here I've got 0 for y. 0 is less than 3. That's a true statement. So that means my test point should be in the solution set for the parabola. So that's shading underneath the parabola. So I've got two sets of shaded areas. I've got a shaded area that you can see in black that's inside the circle, and then I've got a shaded area that's in red that's underneath the parabola. So the double shaded area would be contained inside the circle and inside the parabola. So it's inside the circle, inside the parabola. Right here would be the solution set. Okay. And then it says be sure to find the location of the vertices. The vertices would be the spot here and here where the parabola intersects with the circle. Those are found, remember, by solving a system of equations instead of inequalities. So what I'm going to do is take this system of inequalities and change it into a system of equations. And then solve it using elimination by eliminating the x squared variable So now I have a quadratic equation. I'm going to get it equal to 0 by subtracting 6 and then factor and then two values for y. Now the next step is to find the x values, excuse me, that match up with these y values. But before I do, I want to take a look at where these intersection points are, here, and there's actually one up here. There's a vertex right there, so we need to find those three. So just looking to see if these even match, y equals 3, looks like it matches up with this point right here, so I anticipate that we'll get an x value of 0 for that point. And then y equals -2 kind of matches up with these 2 points, so I anticipate we'll get, possible x values right around 2 and -2 once we plug those in. So next step, like I said, find the x values that correspond with these y values. So for y equals 3, I'm going to use this, I'll just use this one right here, x squared plus y equals 3. So x squared, and then instead of y, I'm going to put 3 equals 3. Subtract 3, we get x squared equals 0. So x equals 0, which was what we anticipated. That corresponds to that point right there. So one of the vertices is the point 0, 3. Now, for y equals -2, I'm going to use the same equation, this equation, x squared plus y equals 3. But now instead of x squared plus 3, it's going to be x squared plus a y value of -2 or -2. So x squared minus 2 equals 3. Add 2 to both sides, and we have x squared equals 5. Square root, we have x equals plus or minus the square root of 5, which the square root of 5 is just slightly above 2. So that seems to correspond with this point right here. It's just a little beyond 2 on the x-axis and down to -2 on the y-axis. And same right here. So the other point, the 2 points rather, would be square root of 5, comma, -2, and negative square root of 5, comma, -2. So this point then would be the positive square root of 5, comma, -2. And this point over here would be the negative square root of 5, comma, -2. Okay, question 6. This is from section 6.1. Solve the system of linear equations using Gaussian elimination. So that phrase means, in other words, we need an augmented matrix and then we need to reduce that to row echelon form. That's what Gaussian elimination means. Create an augmented matrix and then reduce that using row operations to row echelon form. So we'll start with the augmented matrix. This first column represents the coefficient of x variables. The second column there represents the coefficient of y variables. This represents the coefficients of the z variables. And those represent the constant values here after the equal sign. And as we've done several times in class, it is just to review the process of the way this needs to proceed. This value here should be 1, and then our next two steps are to get this value to 0, this value to 0. Then we proceed to get this value here to be a 1, and then we proceed to get this value to be a 0, and then this value here needs to be 1. Once you have 1s along this main diagonal here, then it's a row echelon form. And we can backward substitute and find the value of the variables. So this value here is already 1, so we can proceed then to the next steps, which would be to get this value here to be 0 and this value here to be 0. Now, we need to add something to 2 that will make it equal 0, and that's obviously -2. So to create that value of -2, I'm going to multiply this 1 by -2, add it to row 2. So I'm going to have -2 times row 1, add that to row 2 to become a new row 2. So -1, or -2 rather, times row 1 here creates -2. When I add that to 2, that becomes 0. Here, row 1 times -2 makes -4. -4 plus -1 is -5. Here, -2 times -1 makes +2. Add that to 3, and I get +5. And here, 6 times -2 is -12. Add -12 to -13 to get -25. Now I also want to get this value to be 0. So I'm going to do a similar row operation, but now I'm going to multiply row 1 by -3 and add it to row 3. So -3 times row 1, add to row 3 to become a new row 3. So again, 1 times -3 added to 3 is 0. -3 times 2 is -6. -6 plus -2 is -8. -3 times -1 is +3. +3 plus 3 is 6. -3 times 6 is -18. -18 plus -16 is -34. So again, here we have 1, 0, 0. Now our next step is to get a 1 right here. So the way I'm going to do that is to multiply this entire row by -1/5. So -1/5 times row 2, that's going to replace row 2. So 0 times -1/5 is 0. -5 times -1/5 is 1. 5 times -1/5 is -1. And -25 multiplied by -1/5 is +5. And I'm only going to do this one row operation here, so all the other rows are going to stay the same. So we got a 1 right here. Now the next step is to get a 0 right here. So I need to add 8 to -8 to make it equal 0. So I'm going to make use of this 1 that I just created. I'm going to multiply it by 8, add it to row 3 to create that 0. So the next row operation is 8 times row 2, add that to row 3. That's going to become a new row 3. So row 2 starts here, so 0 times 8 is 0, 0 plus 0 is still 0. Here, 8 times 1 is 8, 8 plus -8 is 0. Here we have 8 times -1, which is -8, -8 plus 6 is -2. Here we have 8 times 5, which is 40, 40 plus -34 is 6. Now, technically speaking, we are not yet to row echelon form. This should be a 1. But, and I mentioned this in class, we're far enough along where we can use the information contained in this bottom row to create an equation of -2z equals 6, which means that z equals -3. So I'm okay using that line of reasoning. You don't need to go all the way to true row echelon form, as long as you get far enough to find the value of one of the variables. Now we take a step up to this row, which represents the equation 1y minus 1z. But since we know that z is -3, minus -3 is +3, and that equals 5. Subtract 2 when we get y equals 2. Now we take a step up here to that equation, which represents x plus 2y. Well, if y is 2, 2 times 2 is 4. minus z, well, if z is -3, minus -3 is +3, and that equals 6. So 4 plus 3 is 7. If you subtract 7 from 6, you get x equals -1. So the solution is -1, comma 2, comma -3. I would recommend now that you check your answer, check your solution. It should satisfy all three equations. So if x is -1, we get -1 plus 4, which is 3. 3 minus -3, which is 3 plus 3, that equals 6. Here, 2 times -1 is -2. -2 subtract 2 is -4. -4 plus 3 times -3, so that's -9. -4 plus -9 is -13, checks out there. 3 times -1 is -3. Minus 2 times 2, that's 4, so we got -7. 3 times 3, -3 rather, is -9. -7 plus -9 is -16. Checks out in all three of the equations. Okay, so we have some matrix operations they're asking us to perform. A times B, we need to check the dimensions. A is a 3 by 3. Matrix B here is 2 rows and 3 columns, so that's a 2 by 3. Notice here that the dimensions don't match. That one's not possible. Now for B times A, B, like I said, is a 2 by 3, A is a 3 by 3. So those inside dimensions match, so this one's possible. I'm going to set it up, and I'm going to set it up using the method, I think the second way I showed you. It's the same process, really. It's just a slightly different way of setting up the problem. So I'm going to write the second matrix here above it. And then the solution will go here, or the product. We've got 6 spots for entries. So this entry right here is going to come from this row and this column. So you multiply numbers that are in corresponding spots here and then add them together. So 1 times 0 is 0, 0 times 2 is 0, 5 times 1 is 5, 0 plus 5 is 5. This entry here comes from this column and this row. So 1 times 0 is 0. 3 times 2 is 6. 0 times 1 is 0. So that's 0 plus 6 plus 0, which is 6. This entry comes from this column, this row. 0 times -1 is 0. 2 times 1 is 2. 1 times -2 is -2. So we have 0 plus 2 plus -2, which is 0. This entry comes from that column and this row, so we have 3 times 1, which is 3, 2 times 0, which is 0, 4 times 5, which is 20, so we have 3 plus 0 plus 20, or 23. This entry here comes from that column in this row, so we have 3 times 1, which is 3, -2 times 3, which is -6, and then 4 times 0, which is 4, so we have 3 plus -6 plus 0, which is -3. And finally, this entry comes from this row and that column. So we have 3 times -1, add that to -2 times 1, add that to 4 times -2. So we have -3 plus -2, which is -5, plus -8, which is -13. So the solution there is 5, 6, 0, 23, -3, -13. Now for part C, this is scalar multiplication and then subtraction. So we got to make sure that B subtract C, they have the same dimensions. So this is a 2 by 3, we're subtracting a 2 by 3, so that'll work. So first thing I need is 2B. So that's just all the entries of matrix B multiplied by 2. and then we subtract 3 times C. Now that's just all the entries of C multiplied by 3. And then subtract. And we'll get a 2 by 3 matrix as a result, and we just subtract entries in corresponding spots. So 0 subtract -9 is 9, 4 subtract 6 is -2, 2 subtract 12 is -10, 6 subtract -3 is 9, -4 subtract 0 is -4, and 8 subtract 21 is -13. Okay. Now number 8. This is from section 6.3. Solving a system of linear equations using matrix equations. So, like it says, the first thing we need is to set up a matrix equation. So the first matrix, matrix A, is the coefficient matrix. These are the coefficients of the variables. Then we have our variable matrix, and then we have a single column matrix comprised of those constant values. Now we're solving for this variable matrix, which means we need to cancel or get rid of this coefficient matrix. The only way to quote unquote cancel or get rid of a matrix is to multiply it by its inverse. So if this is matrix A, I need to multiply it by the inverse of A so that it cancels. So that's the next step, is to find the inverse of A, because once we have that, then we could just multiply it over here, and that'll be our solution, the inverse of A times this matrix right here. So the inverse of A we find using the formula 1 over AD minus BC. That's the scalar multiplier. And then D and A switch spots, B changes sign, and C changes sign, where A, B, and C, D are here. A, B, C, D. So A times D is 4 times -2, that's -8. And then B times C is -3 times 3, which is -9. And then D and A switch places, so this becomes -2 and 4. And this changes sign to +3, that changes sign to -3. -8 subtract -9, subtract a negative is plus, so -8 plus 9 is 1. So it's 1 divided by 1, which is really 1. So we don't have a scalar multiplier. Now this is a little atypical. Most of the problems you'll do or see will have a scalar multiplier that is left as a fraction, like 1 over 5 or something like that. This one just happens to be 1 divided by 1. So the inverse is that. So what we now need to do is take the inverse that we just found and multiply it in this order, inverse of A times that matrix. And like I said, typically here your inverse is going to have a scalar multiplier, like 1 over, I think I said 5 or whatever. I would recommend that you leave that scalar out of your inverse, multiply these two matrices together first, and then take that scalar and multiply it into the resulting matrix as your final step. But here we don't have that scalar multiplier, so I'm just going to multiply these two matrices together. So this top entry is row 1, column 1, so I need row 1, column 1. So it's going to make -20 from those two values, and then 3 times 30 is 90, so -20 plus 90 is 70. And then this entry is row 2, column 1, so I have row 2, column 1. So this is going to make here -30 times 10 is -30, and then this is 120. So -30 plus 120 is 90. And again, if there was a scalar multiplier out front, now at that point I would take it and multiply it into both of these values. But what we have here is x, y matrix is equal to 70 over 90, which means that x is equal to 70 and y is equal to 90. So the solution is 70, 90. And again, we can check this. 4 times 70 is 280. And 3 times 90 is 270. 280 minus 270 is 10. Here, 3 times 70 is 210. 2 times 90 is 180. 210 subtract 180 is 30. So it checks out. Okay. Using the method that I showed you in class, we're going to copy the first column over here and then the second column here. Now, you need to find some products. So the first one, we always start at the top left, moving down to the bottom right. That product there, 2 times -7 times 0 is 0. You always add the products going in this direction. 1 times 0 times 4 is 0. And then -5 times 3 times -6 is positive 90. Now the other products are going to go in the opposite direction, starting at the top left, moving down to the bottom right. Those products we subtract. So here, -5 times -7 times 4 is 140, so we're going to subtract 140. This product here is 2 times 0 times 6, which is 0. And this product here is 1 times 3 times 0, which is 0. Notice you add all of these going in this direction, the ones I have in blue. The ones I have in red, you subtract. Now we just combine this. 90 minus 140 is -50. So the determinant of matrix A is -50.